Today we're going to be studying linear equations for formulas. Now this is going to be similar to what we've been doing. We're going to be studying a couple of new things, but most of what's new is multiple variables. And so it's going to be the same thing that we've been doing with numbers for the most part, but we're just going to be replacing numbers with variables. And this is very important for formulas that we will be using in algebra and formulas that you'll be using in chemistry and physics if you take those courses. Now let's look at a normal equation. 3x equals 12. And this is very simple compared to some of the things that we were working with last time. But how do we solve this? We need to get the x alone. We always need to get the x alone. And so we divide by 3 on both sides. 3 over 3 is 1. And 12 over 3 is 4. Very simple. We've been doing things a lot more complicated than that. But what if we replace the numbers with variables? Okay, let's replace the 3 with a w. And let's replace the 12 with a z. Now, like I said, that's the same thing except that we replace the units with variables. And we're trying to do the same thing. We're trying to get x alone. That is, we're trying to solve for x, which means we need to get rid of the w. How do we get rid of the w? That's right, since we have w times x, we're going to divide by w. And what else did I say? What have I said about 53 times? That's right, whatever I do to one side of the equation, I have to do to the other side of the equation. And what else can we do? Let's see, w over w. What's w over w? That's right, it's 1, which gives us 1x. We know that any number over itself is 1. But anything over itself is 1. Any variable over itself is 1. Any radical, anything over itself is 1. And so we're left with just plain old x. X equals z over w. And what do we do now? We don't do anything because there are no like terms. We don't know the values of z. We don't know the values of w. Now, if we did know the values of z or w or x, we could plug those in, but we don't. And so what is our answer? This is our answer. X equals z over w. Now let's try another equation with variables. Let's try m plus n equals p. Now how do we solve this? Well, first off, I have to tell you what to solve for. I could tell you to solve for m. I could tell you to solve for n. I could tell you to solve for p. Now, if I tell you to solve for p, you already have the answer. It's m plus n. But I'm going to tell you to solve for n. So what are we going to do? Well, we're going to get n alone. And n isn't being multiplied by anything, but there's an addition to the n. We have m plus, so we're going to do what? That's right, just like we did with integers. If we have a positive integer, we're going to add a negative integer. Here we have a positive variable, so we're going to add a negative variable to both sides. The m is eliminated. We're going to bring down the n and the equal sign. We're going to add p minus m. What's p minus m? P minus m is p minus m. They are not like terms. We cannot add or subtract them. So we're going to write it just like this. And so n equals p minus m. I asked you to solve for n, and that is how we solve for n. So we have a times parentheses, x minus y, close paren, equals b. So we've solved for b, but we want to solve for a. What does a equal? Well, that means we need to get rid of the x minus y. Now the x minus y is in parentheses, So we're going to divide by the thing that is being multiplied by a. What's being multiplied by a? Parentheses x minus y, close paren. And so we're going to divide by the same thing. And that's right, whatever we do to the one side, we have to do to the other. So it's parentheses x minus y on the left-hand side and parentheses x minus y on the right-hand side. And x minus y over x minus y equals 1. So we're left with 1a. And since we're trying to solve for a, that's exactly what we want to do. And our answer is b over x minus y. Now you can leave those parentheses there, or you can take them off. There's no need for them to be there. You use parentheses to separate them from something, or earlier in this formula, we wanted you to know that it's a times x and a times minus y. So we needed parentheses there, but we no longer need them. You can leave them there if you like. And let's try a problem where we're trying to solve for one of the variables inside the parentheses. So here we have the same equation, except last time we were solving for a. This time we're going to be solving for x. And so we're going to have to get x alone. And to do that, we're going to have to bring it out of the parentheses. Well, we can't bring it out of the parentheses unless we multiply it by the a. And if we multiply it by the a, we're going to have to multiply the negative y times a also. There we go. And now we have ax minus ya equals b. And you're not really supposed to put the y before the a. When we're dealing with variables, for the most part, not always, but for the most part, we keep them in alphabetical order. There we go. It's in alphabetical order now. And since we're solving for x, we need to get x alone. So let's get rid of everything that isn't associated with x. Ay is no longer associated with x, so let's get rid of that. How do we get rid of negative ay? That's right, we add ay. And whatever we do to the left-hand side, we do to the right-hand side. Except, let's not put things one under the other if we can't add or subtract them. And we can't add b to ay. Yeah, that's better. So in the future, if we can't add this term and that term, let's not put them one under the other. Let's put it over to the side a little bit so that when we bring it down, it's going to look better and make more sense. So we brought down the ax, negative ay, and positive ay is 0, so we're going to leave that blank. We're going to bring the b down. There was nothing to add to that. And we're going to bring the ay down. There's nothing to add to that there. So ax equals b plus ay. Well, now we're looking at something that's a lot more reasonable, aren't we? And to solve for x, we're going to divide a by a. Whatever we do to this side, we're going to do to that side. And x equals b plus ay over a. Now, can we reduce this? Well, we can divide a by a, but there's no a here, so we need to leave that a alone. Now, this is the rule. Just like in the parentheses, when the multiplier outside the parentheses is applied to what? That's right, everything inside the parentheses. Well, with division, it's the same thing. That a applies to both these terms here. So if I can divide this a by only one of the terms, I can't do it. I need to be able to divide this a by both of these terms. So if I don't see an a here and an a here, I can't do it. Now if I do, I can. But as you can see right here, I have one a on the bottom, one a on the top. I need a couple of a's here. So that's our answer. X equals b plus ay over a. Y equals mx plus b. Now this is actually a real formula. We're going to be using this later in algebra. So there's no need to know what it means right now, except that it is a formula we will be using and that we're going to be needing to solve for variables in this formula. Now in this case, we want to solve for m. And we're going to isolate m by eliminating the b first. So we are going to subtract b from both sides. And we're going to bring everything down so that we have negative b plus y equals mx. Everything is in alphabetical order, except that we have another rule that we like to have the positive variable first. Now it's not required, but it makes life a lot easier. There you go. And since we're solving for m, we divide both sides by x. X over x is 1, and so we're left with 1m. m equals y minus b over x, and that is our solution. And here we have another formula. Area equals pi radius squared plus pi radius s. Can't remember what the s stands for. I think it's side, but you don't need to know that. And we're going to treat all these as variables. You're not going to worry about what this is a formula for. And just treat every one of these symbols as if it were a variable. Now, as you can see here, this is not just a, this is capital A, uppercase A, and there's a reason for that, but we're not going to get into it. This is pi. This is a symbol that we're going to be using with circles and things like that. Pi there and pi there. That equals 3.14. You don't need to know that. We're going to just treat that as a variable for right now. Radius, R stands for radius. You don't need to know that either. Again, we're going to be treating that just as a variable, and it's r squared. And we are going to be solving for s, so why don't we take everything that's not associated with s on the right-hand side and subtract that from both sides and bring everything down. So we're going to bring the a down and make that first, since it's positive. Negative pi radius squared. We're going to bring that down, and I probably should say pi r squared, so you'll know what I'm talking about. And that's everything on the left-hand side. Bring the equal sign down. The pi r squared minus pi r squared is eliminated, so we're going to have a little bit of a gap there. And pi r s. And that's all that we have that's associated with the s. So what are we going to do to get s alone? Well, s is multiplied times pi, and it's multiplied times r. That is to say, it's multiplied times pi r. So we're going to divide by pi r. And since we're dividing by pi r on the right-hand side of the equation, we're going to do that to the left-hand side of the equation. And s will become 1s. And s equals capital A minus pi r squared over pi r. Now do not divide this into this. Unless you can divide the denominator into everything above the line, then you don't do it. And since we can't, we're going to leave it right as it is right now. And that is our answer. Now we have an equation with several fractions, with several variables, and we are going to solve for a. Now what did we say about fractions in a equation where one of them isn't a fraction? Turn it into a fraction. There we go, c over 1. And we're going to need a common denominator. The common denominator is going to be b. So we're going to multiply c over 1 times b over b. And where we have an equation where we have a common denominator, we can eliminate the denominators. And this is why. If we multiply this side by b over 1, we're going to eliminate that variable and that variable. And whatever we do to this side, we're going to do to this side. If we multiply this side times b over 1, we're going to eliminate this b here. And so all of our denominators are going to disappear. Now, I believe I showed you how to do this in an earlier lesson. And just all you need to know is that if you have a common denominator on all of your fractions on both sides of the equal sign, then you can eliminate the denominator. So I won't be showing you how to do this anymore. Just know that you eliminate the denominators. Boy, that's a lot simpler. A plus C equals CB. And since we're solving for A, we're going to subtract C from both sides and bring everything down. And A equals CB minus C. And that is the solution to the value of A. And Mr. Wallace likes to leave it like this. I don't. I like things in alphabetical order. And you can talk to your instructor who's ever handling your class, unless you're handling it yourself, and ask them what they prefer on this. I prefer things in alphabetical order unless one of the terms is negative, but in this case it's not. The second term is negative, so I want BC minus C. Okay, we have several crazy things going on in this equation. First off, we have two A's, but I warned you about that before. This is a lowercase a and this is an uppercase A. They are not the same thing. They are not even related. They may be related, but we're going to treat them as if they are not related. And we're going to be solving for a variable that's in the denominator. I don't think we've done that before. And not only is it in the denominator, but it's associated with another term in the denominator. We have 2 minus b, and we're going to be solving for b. Well, the first thing we're going to do is get a common denominator. What is the common denominator? Well, we only have one denominator. It is 2 minus b. We don't have two denominators. We don't have 2 and minus b. Our denominator is 2 minus b. So to get a common denominator on the left-hand side, we're going to multiply a times 2 minus b over 2 minus b. What's 2 minus b over 2 minus b? That's right, it's 1. And we've discussed that before. Anything over itself equals 1. And we can multiply any number by 1, or we can divide any number by 1, and it won't change it. It's going to look different, but it's not. And so it doesn't matter if normally we have the a on the left-hand side of the parentheses, and just for convenience sake, we're leaving it on this side. It technically doesn't matter. This is, since this a is up against the parentheses, it's a times 2 minus b. And that's right, since both denominators were the same on both sides of the equal sign, we can eliminate them. And now we're going to eliminate the a here, since it's a times the parentheses. We're going to eliminate the a by dividing by a. Now, another way you could do this is you could multiply out the parentheses first and then proceed in that direction. That's a different direction. We're not going to do that today. We're going to divide by a on both sides of the equal sign. And look what we have here. We have uppercase a over lowercase a. And we have a over a, and since this a is not in the parentheses, it's all alone. It's associated with the parentheses, but it's all alone. A over a is going to be 1. And we're left with 2 minus b, and we no longer need the parentheses. And since we're solving for b, we need to eliminate the positive 2 with the negative 2. And we're going to bring everything down. And we have negative b equals uppercase a over lowercase a minus 2. Now to solve for a variable, it can't be negative. So we're going to multiply both sides by negative 1. Now on the left-hand side of the equation, we have negative 1 times negative b will equal positive b. Moving to the right-hand side of the equation, we have negative 1 times uppercase a over lowercase a minus 2. And so let's apply the negative first, and that reversed the sign of both of our terms in the parentheses. Our negative 1 became positive 1, and we reversed capital A over lowercase a, that is negative now. And our negative 2 has become positive 2. And then 1 times everything in the parentheses is just itself. So let's remove the 1 and all the parentheses. And that is the solution to b. Now, if you check Mr. Wallace's work, he did that slightly different than I did. Not a lot different than I did, but a little bit different than I did. And we both ended up with the exact same answer. And I would like you to do some homework on page 51. You are going to need a lot of practice to get this down.